All right, you're going to be solving lesson 6.5, solving exponential equations. Here we go. So you're going to learn to solve equations with the same base, and we're going to learn to solve equations with unlike bases. All right, so exponential equations are equations in which variable expressions occur as exponents. So if you look down here in the core concept, two powers with the same positive base, where b is not equal to 1, they're equal if and only if their exponents are equal. So 2 raised to the x power is equal to 2 to the 5th, obviously, when x is equal to 5. But we could use this information to help us solve them when they're a little bit more complicated than that. For instance, right here, we have 3 raised to the power x plus 1, and we want that to be equal to 3 to the 5th power, which means we have to take the exponents, x plus 1, and make sure that it is equal to 5, or solve for x so that it is. Notice that the base is the same right here. The base is the same, 6 and 6, and so the exponent here is obviously assumed to be 1, so 2x minus 3 is equal to 1. We're solving that right here to get x equals 2. And then here the base is 10, and so 3x is equal to 2x plus 3, and we have that equation right here. So we will be doing the exact same thing. So let's give that a try. All right. So base of 3, I have the exponent, 4x is equal to 12. So now I'm just solving for x. So x is equal to 3. Okay, I want you to go ahead and pause the video and work out number 2. What is x equal to? The bases are the same. I'm going to go ahead and work on number 3. So we have a base of 6, so we have 4x minus 5 is equal to 2x. Variables on both sides, let's go ahead and move this variable. So negative 5 is equal to a negative 2x divided by negative 2, divided by negative 2. So 5 over 2 is equal to x. Sometimes you can put it as a decimal. That's fine too. All right, moving right along. What do we do with unlike bases? So looking at the first one, we have 5 to the exponent of x is equal to 125. So what we want to do is actually rewrite this to be 5 with an exponent, in this case, which would be 3. So then we have 5 to the x power is equal to 5 cubed, and then x is equal to 3. All right, 4 to the x power, and then 2 to the x minus 3. So 4 is larger, right? So we want to go ahead and break that down to be a power of 2, which is 2 squared. When we have 2 squared to the x power, we have 2 to the 2x. So 2x is equal to x minus 3, and then we get x negative 3. So the same thing would be here. So let's give that a try. Okay, so this number is larger. I'm going to go ahead and try to break that down to a power of 4. So one thing you can do when you're trying to do that, you want to divide by 4, keep working with different things like that, because we want the base to be 4. So how many times is 4 a factor of 256? And it's actually a factor 4 times. So we can rewrite this, we can rewrite this to be 7, oh, no, that's not what I wanted to do. I'm not ready to do that yet. 4 to the 7 minus x is equal to 4 to the 4th power. 4 to the 4th power is 256. So 7 minus x is equal to 4. So x is equal to 3. All right, I'll work number 8. Here, neither one of them are in the correct form, actually. So you could try like 343 and divide by 49, but we want to go all the way down to the base. So in this case, We know that 7 times 7 is in 49. So we could take this and make it 7 squared, and that's taken to the x minus 2. And then this actually does have 7 as a base as well. And in this case, it's going to be 7 cubed. Okay, now here we have 2 times the quantity x minus 2. So it actually, when we write it out, it looks like this. So 2x minus 4 is equal to 3. So x is equal to 7 over 2, or x is equal to 3.5. You know, that's what this is equal to right there. So go ahead and pause the video and try number 9. Try number 9. Okay, I'm going to go ahead and work it out. We have a base of 6, and we know that 36 has 2 factors of 6, which means that we could take 6 squared, which is equal to 36, and that's that 6x minus 1 is equal to 6 to the 5x. All right, so that's going to be 2 times this 6x. So 2 times 6x minus 1 is equal to 5x. So 12x minus 2 is equal to 5x, and I'm just going to go ahead and subtract the 12x. So negative 2 is equal to, and we're going to subtract this, and it'll be negative 7x divided by negative 7. So 2 over 7 is equal to x. And that's about as far as we'll go into lesson 6.5. They do a little bit with some absolute value stuff, but we won't be working on those. All right.